Kitty draws 3 shapes. Wow, that is quite exciting. 2 rectangles and a triangle. Good stuff, good stuff. And we're given the side lengths, right, in terms of X, Y, and Z. Why Kitty is drawing these shapes, not too sure. Maybe they're designing something on the computer, and when you do that, you actually, instead of giving the dimensions exactly, you can use variables so that if you want to change it, you can change it. Like I just got into 3D printing and I've been learning about that. It's really good fun. So maybe Kitty is designing some elaborate cup holder out of rectangles and triangles. Anyway, back to the problem. We're asked to find the total area. Total area, just the combined area of all the 3 shapes. And we're given x is 6, that's great. And we're also given x plus y plus z is 12. So that's a bit interesting. If we were just given, let's say y equals 3 and z equals 4, we could just substitute in for x, y, and z, get the areas. But we're not, so how are we going to approach this? First off, we could find an expression for the total area in terms of x, y, and z, and then try relate that to the information given. And in case you forgot, we're given area of a triangle, half base times height. So let's express total area in terms of x, y, and z. So total area is area of the triangle plus area of the flat rectangle plus area of the vertical rectangle. Right, this notation is fine. It's not strictly, pure maths, but it does tell us the story. But now let's translate that into maths. So the area of the triangle is half times the base, which is 2x, times the height, which is x. All right, base, height, half times base times height. And we'll add the area of the horizontal rectangle, which is x times y, right? Width times length. And then the vertical rectangle, x times z. Now for the area of the triangle, we can simplify that a bit. So half times 2, that's just 1. Great. And then x times x is x squared. Everything else stays the same. And so what we have here is the total area, but it's in terms of x, y, and z. All right. Looking at these 3 terms, I see a common factor of x, which means we can factorize that. So x times what gives x squared? And x times what gives plus xy? Plus y. X times what gives plus xz? Plus z. And again, these are equivalent. We just factorized it in that last step. Now looking at the information that we're given, we can substitute x equals 6 in for x. We can also substitute 12 centimeters in for x plus y plus z. So instead of x, we have 6 centimeters. Instead of x plus y plus z, we have 12 centimeters. So 6 times 12 is 72 centimeters squared. And that is the total area. So to recap this one, we had 3 shapes. We found an expression for the area in terms of these unknown variables, x, y, and z. We got the expression, but we took it one step further and we factorized it. So these are equivalent. However, having it factorized, we were then able to substitute x plus y plus z equals 12. Right, so if we didn't factorize it, that would be a bit hard to see and you'd be stuck. So in those scenarios, just think, all right, could I maybe factorize it or rearrange it a bit to make it match the information that we're given? In this case, we wanted x plus y plus z, which we got by factorizing. And then finally substituting in the values and evaluating it. We got 72 centimeters.